Sugary snacks, from candies and pastries to chocolate bars and processed desserts, represent one of the most insidious threats to liver health in modern diets. Unlike occasional indulgences, chronic consumption of high-sugar foods delivers repeated, concentrated loads of glucose and fructose to the liver, triggering a cascade of metabolic disturbances that extend far beyond simple fat accumulation. Over time, this persistent stress can transform non-alcoholic fatty liver disease, NEFLD, a condition characterized by excess triglyceride storage in hepatocytes, into non-alcoholic steatohepatitis, NASH, a far more serious and inflammatory stage of liver disease. NASH is associated not only with liver fibrosis, but also with an increased risk of cirrhosis, liver failure, and hepatocellular carcinoma, making habitual high-sugar snacking a silent but powerful driver of potentially life-threatening conditions. The progression from NAFLD to NASH is fueled by multiple converging mechanisms. First, excessive sugar, particularly fructose, overwhelms the liver's metabolic capacity. Fructose is metabolized almost exclusively in hepatocytes, where excess amounts are converted into triglycerides, promoting fat accumulation. When sugar intake is chronic, the liver cannot efficiently export or oxidize all the triglycerides, leading to intracellular lipid overload. This fat accumulation sets the stage for oxidative stress as hepatocyte mitochondria work overtime to process excess nutrients, generating reactive oxygen species, ROS, that damage cellular membranes, DNA, and organelles. ROS accumulation triggers inflammatory signaling pathways, attracting immune cells that exacerbate tissue injury and transform simple steatosis into steatohepatitis. Chronic sugar intake also disrupts insulin signaling, promoting systemic and hepatic insulin resistance. Insulin resistance amplifies hepatic lipogenesis, further increasing triglyceride synthesis while impairing glucose homeostasis. Over time, this creates a vicious cycle. The liver is forced to process more fat, oxidative stress rises, and inflammatory cytokines accumulate, perpetuating tissue injury. These inflammatory responses do not remain confined to the liver. They spill into systemic circulation, contributing to metabolic syndrome, dyslipidemia, and cardiovascular risk, illustrating how dietary choices reverberate through multiple organ systems. Additionally, sugary snacks negatively impact the gut-liver axis, a critical but often overlooked pathway in NASH progression. High sugar intake alters gut microbiota composition, favoring bacterial species associated with inflammation and reducing the abundance of protective, short-chain fatty acid, producing microbes. This dysbiosis increases intestinal permeability, allowing bacterial endotoxins to enter the bloodstream and reach the liver. Once there, these endotoxins amplify hepatic inflammation, accelerating the transition from benign fat accumulation to steatohepatitis. This gut-mediated mechanism demonstrates that the harm from sugary snacks is not limited to caloric overload but also involves indirect immune and inflammatory pathways that silently escalate liver injury. Behavioral and societal factors exacerbate the risks. Sugary snacks are highly palatable, inexpensive, and heavily marketed, encouraging frequent consumption across all age groups, including children and adolescents. For adolescents, whose metabolic systems and liver function are still developing, repeated sugar exposure can establish long-term patterns of insulin resistance, fat accumulation, and chronic inflammation. Adults are equally vulnerable, particularly when sugary snacks are paired with other processed foods, sugary beverages, or alcohol, cumulatively overwhelming the liver and accelerating NASH progression. Even moderate daily indulgences can contribute to long-term liver risk if consumed habitually over months or years. The damage is often silent. Early stages of NAFLD and NASH may not produce noticeable symptoms, and standard liver function tests can remain within normal ranges until significant fibrosis develops. This stealth progression makes high-sugar snacking particularly dangerous, as individuals often underestimate the impact on liver health until advanced disease emerges. Prevention and mitigation require more than reducing overall caloric intake. It demands careful scrutiny of snack choices. Whole food alternatives such as fruits, nuts, seeds, or fiber-rich snacks provide slow-release carbohydrates and micronutrients that stabilize glucose metabolism, reduce hepatic fat deposition, and mitigate inflammatory signaling. Eliminating or drastically reducing refined, sugar-laden snacks interrupts the metabolic cascade that leads from NAFLD to NASH, protecting the liver from oxidative stress, inflammation, and long-term damage. In conclusion, chronic consumption of sugary snacks is a major driver of liver disease progression. The combination of rapid fructose metabolism, insulin resistance, oxidative stress, and gut-derived inflammatory signals transforms simple fat accumulation in the liver into non-alcoholic steatohepatitis, NASH, an inflammatory condition that can lead to fibrosis, cirrhosis, and even liver cancer. Habitual sugar intake silently overloads the liver, disrupts metabolic and immune pathways, and accelerates disease progression. For long-term liver protection, minimizing sugary snacks, focusing on whole foods, and stabilizing blood sugar are essential strategies to prevent the stealthy escalation from NAFLD to NASH.